Lesson 8.4, cubic units and volume. Volume is a three-dimensional measurement. When you think about dimensions, the first dimension we typically think of is length, the distance between one point and another. When we get into area of, say, a rectangle, like the front face of this shape here, of this box, we have a length and we have a width, right? And so the area, of course, is calculated by doing the length times the width. Now, when we talk about volume, we add a third dimension of your depth, how deep it is. You have length, you have width, you have depth. All of those dimensions together go into the volume. And the most commonly used formula for a volume of a box is the length times the width times the depth. But you can think about this a couple of different ways. Looking at this box here, number one, Brienne had a box in the shape of a cube. She decided to use centimeter cubes to find the volume of the box. It took 48 centimeter cubes to fill the box with no gaps. What was the volume of the box? Okay, so each of these cubes had side lengths of 1 centimeter. And altogether, she said she needed 48 centimeter cubes to fill the box with no gaps. So what was the volume of the box? Well, in this problem, they give us the answer. The volume is 48 cubic centimeters. And the way you can write cubic centimeters is you can put cm and then a raised 3 there. But if we imagine that this is a face, and the face is 4 by 3, the face has 12 cubes, and you need 1, 2, 3, 4 of those. That'd be one way to think of it, as far as this front face being extended or multiplied out 4 times. So I have 4 times 3 times 4. That would be one way to think of it. 4 times 3, of course, is 12. 12 times 4 is 48. Let's see how this same concept applies using some different sizes of boxes here. Number 2, find the number of unit cubes and the volume. Okay, so again, we're looking at a shape that's 3 across times 1, 2, 3, 4, 5, 6 times 6 high. And how deep? 2 deep. 3 times 6 times 2. 3 times 6 is 18. 18 times 2 is 36. So 36 unit cubes. And we could say the volume is therefore 36 cubic units. Okay. In the first problem, they told us we were dealing with centimeters. In the rest of these, I think they haven't given us a specific length measurement. They just are using this very general word of unit. So we can't say cubic centimeters or cubic inches or cubic meters. I'm just going to say cubic units. Number 3, we have a 1 across. How tall is it? 1, 2, 3, 4, 5. It's 5 units tall. And how far back does it go? 1, 2, 3, 4, 5. Okay, so we've got 1 times 5 times 5. We can say that it's 25 unit cubes, 25 cubic units. Number 4, number of unit cubes. Well, let's see, we got 3 across and 1, 2, 3, 4, 5. 5 high. How far back does it go? How deep? 1, 2, 3, 4, 5. 5 deep. So 3 times 5 is 15. 15 times 5 you can do as a side calculation. That's going to get you 75. 75 cubic units. Number of unit cubes, let's see. 1, 2, 3, 4, 5, 6, 7 across, times 4 high, times how deep is this? 1, 2, 3, 4, 5, 6, 7. I think it's 7 deep. I'm going to double check that. 1, 2, 3, 4, 5, 6, 7. Yeah. Okay. So 7 times 4 is 28. 28 times 7. Let's just set that up as a side calculation here. 7 times 8 is going to be 56. 6 comes down, the 5 gets carried. 7 times 2 is 14 plus the 5 gets us 19. So we had 196 cubic units. Number 6, it's 2 across times 1, 2, 3, 4, 5, 5 high, times how deep is this thing? 1, 2, 3, 4, 5, 6, 7, times 7 deep. 2 times 5 is 10. 10 times 7, nice easy calculation for us, 70 cubic units. And number 7, we have a box. It's 1, 2, 3, 4, 5, 6, 7 across, times 2 high, times 2 deep. 7 times 2 is 14. 14 times 2 is 28. So main takeaway from this first look at volume is just the understanding that it's a three-dimensional measurement. And the 3 dimensions, when we talk about a box, or sometimes called a rectangular prism, is your length and your width and your depth. And obviously in multiplication, you can multiply those 3 factors in any order and end up with the same final product.